Good morning, everybody. We're just doing our pump-up dances here. Welcome to Hackster Café, our weekly interview show on Hackster.io, where we talk to hardware badasses. And we definitely have a really cool team here today. We're talking to the team from Flux.ai. Welcome, Matthias, Brooks, and Kerry. How's it going?
Great. Happy to be here.
Happy to be here, Alex.
Yeah, me too. So tell us about Flux. What's the deal?
I'll take this one. Look, we got fed up with how cumbersome it is to design PCBs, and we decided to build better tooling around that. That's the short story. The long story is that I've been going to Burning Man for 10 years and building lots of animatronics projects, and I took some time off in 2019, and then wanted to do bigger stuff with more people and more everything. And I realized that, tooling in the space, I had essentially duct taped together some components in a shoebox. And then I needed 12 versions of that. And while building the third one, on weekends here with friends, I realized, man, why didn't we do a PCB? And then I remembered, because making PCBs sucks, even though it should be awesome, right? And then, I hadn't worked in hardware in like a decade. I used to work at Siemens in Germany, and I used to have two mid-sized companies in Germany doing like hardware software with custom manufacturing since then. And I realized, look, the tooling hasn't even improved, right? It's just as bad as it was in the 2000s, when it was as bad as it was in the 90s when I went to college, And so I couldn't let that stand,
So what are the improvements that you've made over that? Obviously, for me, the really standout feature of this obviously is the collaboration aspect of it, where you mentioned that it's kind of like the Google Docs for PCB design, which is, I think, a great way of putting it. But yeah, what else did you hate? What sucks?
Yeah.
And what do you have now that rocks?
It's a good question. I mean, I think, there was like on high level, there was like three things. It's like, that but the advantage of duct taping something together in a shoebox, for a bunch of boards you stole from other things, is that you don't have to start from scratch, right? You don't have to design your own buck converter. You don't have to design, right, whatever it is. But if you want to make a PCB, you're going to be making all this from scratch. You're going to spend the next 3 months just doing that before you get to the fun part. And so, this like whole idea of like never starting from scratch, like in software, right? Like we never start from scratch. Like if I want to build a GPT chatbot, I'm not going to start with writing my own operating system and then a browser and a web server. This stuff, there's plenty of offerings out there. I grab what works best here for me, and then I can focus on the actual thing I want to do, and not sitting there designing my own buck converters, right? So that was a big thing. And then like I think with the existing tools, it's just full of busy work. It's like writing software with like a text editor, which I guess you could do, but like you wouldn't. There's just, you just think about a simple task like, ground copper fills. Like, do I want to sit there 2 days and draw all these islands by hand? No, I don't. That's silly, Or like place all these like vias to stitch them together by hand. No, I don't, And then just like, but if you want to work with others just for design reviews, let's say I made the hardware, somebody else is going to make the firmware or the enclosure. There's like so much friction to collaborate. And I think this goes beyond just PCB design tools, but CAD in general, right? It's like it follows like a paradigm from the 80s where we have like some native application and we send some files around, and then, you can't open that file because you have the wrong version of that software, And so you're going to spend now 2 hours downloading the 4 GB package, and then, but you don't have the license for that either. So pay another $10,000, and now you can finally open and review this thing. And it just seemed like from a long gone world if you had spent a while in software,
I feel like that, that's similar to what my experience was that made me switch to Onshape for 3D modeling, is that being able to do it in the browser meant I didn't have to dig around for like, where did I put that file? What version were we on? Yeah. And like, you've got a wonderful page on the Flux Method, which I think kind of digs into this stuff that you were talking about. Obviously, the templates part, which I think is wonderful. We'll look at that in a minute. But yeah, reusing components, especially ones that, experts have built, the collaborative aspect, and staying in the flow. Another thing that I think we ought to mention is a built-in spice simulator. Very cool. But if you'd like to tell us, like, briefly, what is this thing you call the Flux Method?
Yeah, I think something we realized, right, when we started, like, thinking about what a better tool would look like, is that we realized, right, that the existing tools are more like pixel drawing tools. You're really Bob Rossing the design together. And that what we wanted was like something more declarative, something more parametric, which is popular in CAD design, but not in EDA design, right? And so that would take then a different approach to how you design something, how you approach that, how you think in like reusable components, and so I think that's what we're trying to get at with the Flux ones, to just explain that, that way of thinking and working.
Yeah, these sublayouts are an interesting part of that reusing components part. And I just got to say, the documentation on here is very beautiful, and I care a lot about that. So we at Hackster are all about tutorials, so I love it.
Yeah, big props here to Nico and Jarvan on the team who work on this all day.
Mm-hmm.
Nice. Yeah, so
well, I can take the sublayout thing. I just, sublayouts are, I mean, it's like Matthias was saying with software. You don't start from scratch in software. You import libraries. You use different things that you can find on GitHub. And so we're trying to be a little bit of that sort of GitHub vibe, but for hardware, where, again, do you want to spend the next day designing your buck converter, or could you do it once, save that as a sub layout, and then drag it and drop it into every project you do in the future? Or even better, maybe there's someone you trust who's made it already, and then you actually never have to design your own buck converter, which is frankly even better, just like you don't have to invent JavaScript every time you want to start doing something with that. So that's the exciting part about sublayouts.
Yeah, and that's something that you can filter for in this library, right? I made an account really quick on this, and got very excited about the fact that you have these templates basically for different, like a 6-layer stack up in OshPark, a 2-layer stack up in OshPark, but also like if you're working with JLC PCB, there's a multi-layer stack up. So that is blowing my mind, first up. But also, let's see, is it in here? Yeah, you can filter for what you're looking for in here and look for sublayouts themselves.
Yeah, exactly. And this even expands, right? I mean, great uses that Kerry always has is like, look, you need an ESP32 with 2 USB plugs and Wi-Fi, right? Why start from scratch? You can start from somebody's existing public project, or somebody, a project that somebody in your team or your company has built, and start from there, right? Instead of starting from scratch. And I think that's really the power of collaboration and community,
Cool. So now we've gotten a little bit of an overview of what the tool is and how people use it. You folks have some really interesting background stuff going on that sort of brought you to this level. So you mentioned that you, Matthias, you worked at Siemens. A couple of you, it seems like you met at Facebook. Is that right? Or did you not know each other while you were there? You just happened to.
No, we know each other before.
Matthias and I knew each other. We met in the Mission District of San Francisco like 12 years ago at a cafe. And we actually have run one other startup together previously. And then we both wound up at Facebook at the same time, but we were working on different projects. And then Kerry was at Apple before this.
That's right. Yeah, I worked on the iPhone team for 5 years. I worked on the iPhone 5S, 6, 8, 10, and 11. And then I left to make some intelligence equipment for the government. And then I decided to join Flux to help solve a lot of the problems that I was experiencing along the way. Making hardware is really hard, and I had so much frustration trying to accomplish, even at Apple, trying to accomplish building the iPhone and getting stymied by my tools. So that's why I decided to join Flux and work on this problem.
What were the particular things at Apple that were bothering you? Was it the collaboration aspect? There's also this version control. There's so many things you've got built in here that I haven't even mentioned yet. But yeah.
Yeah, I think one of the things about Apple is that you would assume that Apple is using these very futuristic tools, but we were using a very old version of Cadence from many years ago. It wasn't even the most recent version of Cadence. And we would access it through a Linux terminal. And so there's this hilarious story where I had to review, somebody pinged me when I was in China at the factory, and I was on the bus headed to the factory, and I only had 3G on my phone, and they needed me to review this design as fast as humanly possible. And so I tethered to my phone, which was over a 3G connection, and booted up, the Linux terminal that I needed to use. And I had the exact same performance as I did at my desk. And I was like, this is crazy. Like, I need something a little bit better than this.
Yeah. You were going to say?
I was going to just add, but I think this was one of the unique insights also, right? That like I came across this, as I said, for like Burning Man projects, and then I started talking to friends like Kerry and Patrick who worked at Apple, and I realized, oh, it's even worse for them, right? And that we all wanted the same thing, and yet nobody had built it, which seemed crazy. I mean, I will also say that like now I know why nobody done it before, because there's a lot of work to build a cat tool in the browser. But look, we're here now, so.
What were some of the challenges that you faced while trying to put it in the browser? Because I've only worked with desktop-based versions. I know that there are other browser tools out there. There's Patcher, there's Upverter, Easy EDA is in the browser, isn't it? And could you tell us a bit how your tool differs from those?
Yeah, good question. I mean, I think Upward, I'm not sure. It seems like defunct these days, so I'm not so quite sure what the status there is. But I think the challenge we face is like, what Easy EDA and Upward did is they just stuck to the 2D domain, right? Which I guess is like, it's fine for 2D layout, right? For this like abstract view you have in tools. But, our ambition here is like, well, our mission is to take the heart out of hardware. And while we're starting with electronics, because we felt like that was the biggest opportunity and was close to our heart, ultimately, right, any board needs an enclosure, and whatnot. And so we want to expand here to mechanical design. And so we wanted this to be able to support 3D just from the get-go, And we also frankly wanted to be able to like just visualize your board 3-dimensionally as you design it, because we knew that like, this like presentation aspect and review aspect was big, and that also like we live now in a world where like for any component, there is a 3D model. And so you can like, without any extra effort, visualize the whole thing, what it's going to look like, and to see if it fits in the enclosure or whatever you want to do. So anyways, so that was, I think, a big challenge since, this, but for native apps, 3D has a long history, and it's well understood. I mean, like games all do that, for example. But in the browser, it's like a very new idea. And it wasn't, we had seen Figma do this really well for like a large millions of objects 2D canvas kind of thing. But we hadn't like seen this for like very large 3D applications, really, And so I think that was challenging. And I think then by just the complexity of an EDA tool that you have, right? You have a schematic editor you need to build. You need to build this mechanical editor. You need to, the simulation piece, the library, the real-time collaborativeness of it, it all adds up really quickly, And you realize why nobody has done this, or like why the incumbents don't just duct tape remote collaboration into their products.
Yeah, what have you seen be the most exciting to the community in their response to this so far? You just launched pretty recently to the public in the middle of February, from what I understand. But you had some beta testers beforehand. What have people had the best reaction to when they're like, "This is really magical"?
Oh God, I mean, the best reaction is actually a reaction. I think Kerry had like in a research session with somebody, I think around December, where somebody said, "Hey, look, I can do something here now in half a day that would have taken me like 5 weeks and something like Eagle, And I think that's where it was then very clear that we like finally like crossed like a line here, and where people were seeing what we're trying to do, and it was creating value.
You can start feeling that benefit. I felt that myself, actually. I've used Flux for my hardware startup, and I had been trying to create a board in Eagle, and it took me about 3 weeks to do that. And, your process is you have to go and make all your parts, and then you start your schematic, and then you have to go in and make your layout. But I started with the free version of Eagle, and so then it took me a week and a half to realize that I actually needed 4 layers, and so I had to transition to the paid version of Eagle, and then I had to start over because there's not good linking between those things, and I just decided to try and do it in Flux. And because of the concept of sublayouts, because you can leverage other people's public projects, I was able to do it in 1 day. And, that was really transformative, I think, to be the only person at a very small company building hardware. And all of a sudden you free up 2.5 weeks to do other stuff, like build other boards or plan your marketing around this product. It's huge. It's really transformative.
Yeah, especially for small teams where everyone's kind of doing a bunch of different things at the same time. Like,
That's right.
personally, I'm designing a PCB for Hackster for us, doing a ruler so that we can do it as a little giveaway. And that definitely does, like, I was trying to do it as like a breakaway, like one with breakaway pieces in the middle, and learning that whole workflow now, which definitely maybe I'll ask you about that later. But you know, it's sucking up a bunch of, it's taking a ton of time. And so it's like late. We wanted to put it in some gift bags a couple of months ago, and it's like, no. And also, like, I need to get prototypes back. So time is always a factor. It like multiplies on itself. And then, of course, I also do video and stuff. So it's like, I love the sound of that, just like getting all that time back. We have a couple of questions from our community who are joining. Arnold says, how big is the part library compared to the Altium Vault, for example?
Yeah, good question. I mean, I think there's like about 200,000 public components in the library you can use, and that includes sublayouts. I'm actually not sure how big Altium's is, but you know, that's our size.
But people can add their own as well, right?
Oh yeah, totally. I mean, you can create your own components. You can upload components from other tools, from other and other file formats. Yeah, and you can either just keep them to yourself, you can share them just with your team, or you can make them publicly available to everybody. And so yeah, the 200,000, these are public ones. So this is like plus all the private stuff that people have.
And two things there. The private versus public thing, this is part of your pricing tiers, right? It's kind of like, again, I'm using Onshape as an example because I love them. But you know, all kinds of tools do this where you have sort of unlimited public projects, and then if you want to go private, then you have to pay.
Yeah, exactly. That's the threshold we chose. Very similar to like GitHub or other platforms here. You know, I think we want to make it really easy for people to get started. Everybody has like 10 private projects included in the free plan, so you can get the wheel spinning.
Oh, cool.
And then, you know, and we figured like 10 is pretty generous, you know, and then like, look, if you start making more private stuff, then, you know, this is probably commercial work, you know, and I think we have a very fair priced pro plan at $12 a month, you know, where you can then have infinite private projects.
Yeah, 10 private projects is really nice. Let's pull that up really quick. And the other question was, let's see, we're talking about public versus private. I may have lost my train. Oh yeah, the other thing being how everything that people share in terms of custom parts goes into a common library if they want to share it publicly. And so, for example, working with KiCad, I've installed like the Spark Fun parts library and the Adafruit parts library, and my partner just got started with KiCad and is trying to use the default parts library, which is missing so many things. And you know, even trying to translate our experiences between each other, like, oh, you can look for that. Oh, you can't look for that thing. I kind of love the idea of it all being in there in one place. Is there a way that you're going to deal with? I mean, hopefully people wouldn't duplicate the same parts because it would already be there. But yeah, are you anticipating having to deal with duplicates?
I mean, we are dealing with duplicates. I mean, I think, you know, it's like, I think you're right that people are unlikely to just add something that already exists, because people first always look if it's already in there and only default back to creating something on their own or importing something if it didn't exist. But I think what we see a lot is people improving upon each other's work, you know, and it's very similar to the vibe on GitHub, where you come across something and be like, hey man, wouldn't it be cool if it also did that? And you just go in and fork it and add that functionality, right? And then something we're still working on is then the ability, just like on GitHub, to like that, just open a PR, propose a change, and so you can contribute that back into the original library, you know. But that's kind of like what we're working towards, to here, that we can build the ultimate library in the world, right? Where the components cover every aspect that you might want and have the 100% accuracy, you know. I think if you also think about components in Flux, right, they're not static and that they're just a symbol and a footprint, right? We have a whole user code runtime in there, and so you can automate these components. And you know, Kerry can maybe show this while I say, but you know, something users invented here is the idea of generics. Kerry, do you want to show us that?
That would be awesome.
Yeah, just bringing that up real quick.
Yeah. And while he does that, so yeah, in that sense, the components in Flux.ai like apps on your iPhone, you know. And the distribution is the part library, the component library here, right?
What about like variants? So for my projects, for example, I designed a little 6x6mm button footprint, a very common footprint, but I put like a little smiley face in it. And I like to put little Easter eggs in my custom footprints sometimes as like an artist. And I'm curious if you would support, like, it's the same as this 6mm button, but it looks slightly different or something. There could be a whole ecosystem of sort of bespoke stylized components.
People do that, yeah. And and you can also if you want your signature as Silk, people have turned that into components too, right? That they use themselves. So yeah, totally. But you're not constrained here to share sublayouts or footprints to the library. You can also just share Silk art, right?
That's a good point about the apps, though. Like when cell phones were first sort of like hit it with their heyday, when they had hardware keyboards, all the apps were first party, right? And so that really limited creativity, and it didn't create an ecosystem for opportunity. But then the Apple App Store opened it up, and all of a sudden there was this quantum shift, right? And now that's obviously the way to do it because it's so much easier. You don't have Nokia authoring every single app. You have this whole ecosystem. So
at least on Android now. It seems like Apple is, they got it a bit more locked down, but like for sure,
yeah. So we want to enable that opportunity as well, and not make it this sort of static, monolithic object that you import. It's very dynamic, and there's a lot of opportunity for people.
Kerry, you want to show us? Are you ready there?
Yeah, it's all set.
Oh, great. Go ahead, and I'll put you on. Oh, I had to scroll. Sorry, too many windows. We really have so many guests. This is really fun. But yeah.
So we were talking about user code as far as parts go. So when you author parts, you can create the schematic symbol, and you can create the footprint. You can also create your own custom user code in order to have those, in order for those parts to have special behavior. So the simulation models, we're just showing a live simulation here. The simulator is special in a couple of ways. One of those is that it's on by default. And also the simulation models here are user generated. And so I want to just show one of these real quick, this LED. It has some special behavior where the user has programmed in the threshold voltage. We can actually see that and change the threshold voltage of this LED. And we can see when it's turning on. It's not turning on when there's any voltage. It's turning on when it would in real life, because the voltage across it is surpassing the threshold voltage. And here is where that's done. And so this is the part. We can just go in and open that particular part. Since this is a public part, we can see the symbol, we can see the user code, and we can see the footprint here. And so I think this is a really cool opportunity for people to create the behavior that they want to see in Flux, like Brooks was mentioning. It's not all controlled by us. And we've been surprised a couple of times by users creating things that we never imagined. And I think that's a lot of the excitement here, is to see what happens, what the community generates.
Oh, do tell. I would love to hear what people created that you were
show generics. Show the generics.
Ooh.
We'll show generics.
Okay,
Let me
cool.
just open another.
It's crazy. It's crazy cool. It's super, super cool.
So this is one of the things that I was talking about when I was saying the flow in Eagle was create all your parts and then make your schematic. That really slows me down, because when I have an idea of what I want to accomplish, I want to go and accomplish it. I don't want to go and make a bunch of parts. And so you have some options where you can pull in SparkFun library, Eagle library, whatever, Adafruit library, in order to start from those parts. But what I really like in Flux is that it follows the way that I want to design, and that's sort of where generic parts comes in. Often if I'm designing a circuit like an instrumentation amplifier, for instance, I want to put some resistors in, but I don't know exactly what value I want. And so it's silly for me to go in and make a very specific part with an NPN and a package code and all of this stuff, because I'm just going to change it later, and that's wasted effort. And so what we've done here is given you the option to change all of the features of this part. And so, maybe I have this in here, and I have a generic capacitor, and I want a particular cutoff frequency. And so I'm just going to guess that maybe I want 10 microfarad here, and then, maybe we'll do whatever, 100 ohms here. So I think you have the option to do some of that in other tools. What is really special is that in this version of generic parts that was user created, you can go in and change the package size. So say you're routing this, and you're like, hey, I realize that I'm going to use a bunch more current here. My traces are very wide going to it. Actually, I need it to be like half a watt instead of 1/8 of a watt. I'm just going to bump this up. And then I think that I want a 1206, so I'm just going to make it a 1206. And then I can go in and add manufacturer part number at the end instead of doing that at the beginning. And I just really like how this matches the flow on how I want to design a lot closer. I don't want to specify all this stuff up front. I just want to get it done, and then I'll add the specificity when I want to.
Nice. This is nice.
And so this is enabled with user code that's inside of this part. So this part actually has a ton of footprints hanging out inside it. And then the user code is listening for the property. It's generating a list of properties. And then when you select the property, the user code is saying, okay, we'll swap out the asset dynamically for you.
That's pretty cool. But you have to encode all the different options inside of the part?
Yeah, exactly. You know?
It makes sense.
There's different ways to do it, but I think the cool thing is here that from the user code, we give you full access both to the schematic and to the mechanical, to the PCB editor, right? And so there's some other cool demos. I'm not sure if you have that there here, Kerry. I'm going to share the link here in the private chat quickly, where a user wanted, has essentially automated a switch on the PCB board and the LED. And so in 3D view, you can actually switch back and forth. And this is like a simple little demo, but this is something a user built, So if you go to controls,
open the control panel there. Yep.
Yeah. And so we see on the upper right, the LED is on now. And if we close that, look, you got to select the switch. There you go.
Ah, look at that.
Yeah, and so you made that interactive, right? And so this is the kind of stuff you can build here. And so that's, I think, a very exciting aspect here. But in many ways, it's like what we try to provide you here is more like an operating system to build hardware, And you can imagine, we talked about this, that people share like just silk art in the component library. But you can imagine here also like just generative silk art here, right? QR code, for example, you need a QR code on your board, You could build a component where like you can just input a string and the user code here converts it into a QR code for you, So
I love that idea. I would totally use that actually, because I have like a specific page that I go to that a friend of mine built on the internet, and that's like the one that I use, and it's always like running back and forth. And then like if it needs to have a logo in the middle of it, then or like take away the logo because it's not in the brand spec, I always run into that because I'm kind of a loose cannon when it comes to design stuff. But yeah, like just being able to have that built into the tool would be really nice and cut out a bunch of steps there, which is exciting. We have another question from the community. Are there plans to support FPGAs with 0.8 millimeter pitch bulk rate array packages from FPGA Zealot appropriately?
It's very possible that we already do. There's no limits on the pitch of the components at this point. I think that would be more governed by your design rules rather than anything that happens in our editor. 800 micron pitch isn't so bad. So I'm just gonna, in the background, take a look through the parts library and see if I see any with 0.8 millimeter pitch, and then I'll report back.
Cool.
Maybe there's a subtlety here where I think we get asked a lot, like, will we add a part and that sort of thing. The library is 100% user created. The only part that we made is the terminal, because that's the Genesis part that everything is built on. But every other part in our library is created by the community. So when people ask, like, will there be this part? I mean, my answer is, yeah, be the change you wish to see in the library.
Yeah, and you can band. Oh, sorry, just to add that, you can band together also with other users. We have a very active Slack community, where people organize, and also help each other out, with these kind of things.
Yeah, I was actually very surprised to see this Slack community on there. If you see where I can find. Oh yeah, it's in your page footer. Just because I assumed that was like a company thing, but it is for. Oh, we gotta re-add this. There we go. But it is very much something that is available for your community. Is that like the same as your company Slack, but there's like open channels, or? Okay, that's what I figured. But it's like a community Slack, almost like a. Yeah, I love that. And what kind of things can people expect to find there? You mentioned on the site that there may be like experts hanging out there that could help you with your designs. Maybe you would be able to share your stuff and show it off. What else?
Yeah, there's a bunch of power users for sure there. I mean, but I think most of our team also hangs out there if you have questions or run into problems, we host competitions, I think monthly now, those all happen there. And it's also just like a place for people to show off what they build, There's a lot of people like, they're really excited about building out a component library, and they share, hey, look, I just added like all the switches of that series of switches, Yeah.
We have a competition going right now where you can go vote on the winners. I think the projects are in, but you can vote on it. It's like an energy harvesting competition.
Ooh, I'm gonna go check that out.
And it looks like we have 4 finalists that you can vote on.
Cool. Where would I find that?
That's in the announcements channel, in the first channel.
In the Slack. Excellent. I'm gonna go check that out after the video.
Let's get the link to it. To the actual post.
And I'm sharing it as well if you wanted to put that up on the screen real quick.
Thank you. Let me see if I can get this in Firefox. No, it wants me to sign in. But we can, if you'd like to drop it in the main chat here, or I can do that. There we go. And that should go to at least our YouTube and Facebook. If you're joining us from LinkedIn, you can check back after. I'll put it in the description to the video, so just scroll down. Let's see. There was a thing. Oh, yes. On the subject of community stuff, you also have job postings, but also all remote, which is wonderful to see, but also internships. You have got a bunch of intern positions opening up. Tell us about this for people who want to it seems like a cool opportunity for people who want to get started in hardware.
Yeah, absolutely. I mean, I think we started like an intern program like a year ago or so, and it's been going really great, So I have like both interns here with the CS backgrounds, but also like hardware backgrounds and the E backgrounds. And it's been really incredible, to have them come in and like just own real projects here, right? So I think we have right now like 2 interns with us, and always looking for more people here who want to join and see what we're doing and help out really, and have impact here towards our mission, whether it's like on the software engineering side, or just on the hardware engineering side here, and build more stuff with Flux and expand tutorials, expand the documentation, engage with the community. There's a ton of opportunities here across the board.
And I gotta ask, because I'd ask anyone this, is it a paid internship?
Yeah, they're all paid.
Yay! Love to see it. All right. I feel like there was something that we were waiting on Kerry to answer for us. Kerry, are you ready?
Oh, the FPGA. We don't currently have one in the library, but as Brooke said, be the change that you want to see in the library, and so you can go and create those parts on your own.
Yes.
But again, if you feel stuck, if you know what you want to make, but you're not quite sure how to get there, engage with the experts in the Slack community, and you'll probably get some help. You will.
That's right.
I'm sure you'll get some help.
We're standing by to help out. I'm there if you want to ask me electronics questions. You can just DM me or ask in the questions channel. There's a lot of people hanging out, willing to help you on your projects and help you get it done.
Nice. We have a question from Vasil, who says, can I export a 3D model of my PCB from Flux? I've been playing around with these 3D models, and it's so much fun in the emulator here. But yeah, can you download it?
Yeah, you can. We support Collada and STL, I believe, right now.
Yeah, if you go to the Flex menu in the upper left there, we have an export section, and you can check out what's available there.
Aha!
There we go.
Here we go.
Export.
Gerbers, bill of materials, pick and place, 3D model. There we go. There's your answer. And you can export it to KiCad even.
And there's a feature request in our feedback forum to also add step support, So if you want step exports, go hit upload there.
Nice. We have another question. Is breadboard view available a la Fritzing? I feel like this is something that, generally is not included in PCB tools, but Fritzing for sure, since they're sort of based around that originally. But maybe you can answer this better than I can.
Yeah, the short answer is no, it's not. I think, we have a lot of ideas to like offer different kind of views on your project, right? And so like this 3D view is one of them, the schematic view is another, the 2D PCB view is another, and so breadboard also was on the list, but hasn't made the cut yet, But certainly, but another idea we had that Brooks is really excited about is like also like the idea to look at your product in a tabular manner. And so something that we're exploring, like what are the different ways to look at a product that provide value to users.
We have another question about this interface. Of course, at the top, you've got the schematic, code, and PCB tabs, which it makes it very simple to switch between the different parts of your project. And the code, I can imagine there being some ambiguity here. So Vasil asks, can you run Arduino code there or what? I'm assuming.
So that's a great question. I mean, so what you can do today is you can mock the behavior of a component like an MCU, like an Arduino. There is no native support for Arduino code itself today. But something we're planning to do is just to add support to import custom NPM modules, for those who are like familiar with the JavaScript ecosystem. And there is, JavaScript, there is NPM libraries to compile bytecode and Arduino code. And then you could perfectly well write Arduino code here and automate your Arduino with the simulator, or code for any other MCU you can think of, And so I think that's at least the current plan, but to essentially provide more of the infrastructure for users to do these kind of things, and then not be limited to Arduino or what other MCU you want to use, but allow users to build out the ecosystem themselves.
Ha! Now this is an exciting day because I'm also learning about. I didn't know there was a Node package for Arduino. That's so interesting.
Mm-hmm. Yeah, there's a couple ones.
There's probably
It's been a while since I looked, but there's like a bytecode compiler available, and then there's also an Arduino to bytecode or something converter available. So you can stitch these together and make it work, and they work really great.
Yeah, in the past I've used Johnny 5 with, what was it called? Oh my gosh, the thing where basically you install a sort of receiver sketch on your Arduino, and then it receives the JavaScript from your computer and runs whatever that is. But it's more of like a little wrapper kind of thing, or a communicator, as opposed to like being able to compile code for Arduino from JavaScript. Yeah. So that's very exciting too. Huh.
Yeah, but what you can do today is, like I said, you can definitely mock the behavior. If you wanted to do something where, like, hey, look, if on pin 5 there's 5 volts incoming, then shoot out a sine wave out of pin 14. That kind of stuff is really easy to do today, and you can both do this with user code, or you can also draw a little schematic to mimic that behavior, if you wanted to.
Oh yeah, Kerry, do you have the 555 timer up? That's kind of wild to show. You can simulate. Okay. You can simulate parts using actual schematics on the inside. You don't have to write code necessarily. So we have like a fun example of a timer.
So a 555 chip that actually works in the in the circuit. I love it. I noticed on your while we wait to see if that's possible, there is in the featured project section a simulator models tag. Oh, went to the wrong place. Well, that didn't work out. But in that, let's see, Explorer projects is here. Simulator models. Yeah, here we've got a multi-vibrator flip-flop circuit, a little blinking LED. And my guess is that it will actually work if we load it up here. Oh yeah, we got stuff going on here. Similar to what you were showing off earlier.
Mm-hmm.
Oh yeah, so we're in the
this is the exact one, isn't it? Yeah.
Oh my God, look, collaboration.
Collaboration! We're looking at the same thing! But then there's also like a light detecting resistor one. Light dependent resistor, is that what that stands for? I thought it was light detecting. I'm learning so much. What kinds of things have you folks learned from building this tool? I'm really curious, since we're a tutorial community all about electronics. It doesn't have to be an electronics thing though. I'm learning some unrelated stuff today. But tell me, maybe start with Matthias. What's the biggest or most exciting thing that you've learned from building this?
Yeah, we do internally weekly demos on Fridays, and we share what we learned that week. But now you ask me for the biggest thing I've learned along the way.
Or most exciting?
I think I learned more about browsers than I thought I had to. Very unrelated to hardware, but maybe like more hardware related. I mean, we're working right now on like fully automated impedance matching, right? And so I've learned from Kerry really a lot of the fundamentals. In my mind it was always like, well, you just adjust the length and you have the right width, and then that will be good enough, But it's like, there's a lot of like details to it, that have been really interesting to learn, and I won't recite those, but I've learned a lot, and Kerry's really the man to ask about this kind of stuff.
Cool. Well, Kerry, what have you learned?
I'll say that I've done a lot of teaching. I will say that. I think it's really cool to see. So the company is primarily software engineers. There are, of course, a bunch of other people. The excitement that this group of people has for hardware design is super inspiring. And I love teaching people hardware design who are really excited about it and want to build stuff. I think that's what brings a lot of us to do this work. And so I have done a lot of that internally, but I also do that externally. We have pretty much bi-weekly events, and I've done some where I teach how do you increase the efficiency of your power supply design? Like, what are some things that you would tweak? We did one on impedance matching that was a public session. Yeah, let's do a session together. That'd be really
fun.
Yeah.
This is my grand plan.
This is, by the way, a great example, right? When we started this, right, I had a little bit of an imposter syndrome because I hadn't worked in hardware for like a decade, and so I spoke with this to one of our early angel investors, and he said, "No, Matthias, I invested because you're an outsider, right? Like the insiders, we always just get the same kind of thinking." And I think one of these like things with impedance matching was that I just wanted the software to do the job for me. Why do I have to know all this stuff, and do all this math here, right? To do something that should be so simple. And so I think that's been really interesting here working together, and then having Kerry join us, right, who knows the fundamentals so well and has sweat the details at Apple for so many years, right, that I think we can come up here with much better solutions. That's also how the copper fields, the ground fields was born. It's like, no, the software should do this for you,
I think impedance matching is an incredible example of that, because I think everyone who currently works with impedance control knows that the flow is that you go to some random calculator website and then you put in some of your information and you guess to try and figure out the answer, and then you have to go and define your constraints in the system and then do all of this stuff. And then maybe it works and it doesn't tell you if you're wrong. And so we should integrate all of those things and automate that and have it do that for you and tell you if it isn't the right impedance. Like these are
they'll know about
basic ideas.
It makes so much sense.
Yeah.
I just wanted to say I have a funny story regarding what I've learned.
Yes.
Matthias mentioned that we're outsiders. Some of us are outsiders. I am. I'm a designer. I'm a product designer. I was last working on Facebook stories. So that's about as far from hardware design as you can get. And so when you asked what I learned, I was like, everything. Literally my job is to like show up every day and go learn about a new thing and bring it back to the team and be like, okay, here's what I learned. Copper fills are this and that, and then verify it with Kerry and then work on our own spin for it. I mean, like a great example is you'd asked earlier, how do we differ from other products? Mm-hmm. We don't run DRC, design rule checks, at the end of your PCB layout. We design using DRC. We have this system that's sort of like CSS. We call it rules. And that's like a great example of like really, I went and I looked at DRC and I looked really hard. I looked for a long time and I was like, what is this? What is this doing? Why is it going at the end? And as an outsider, I didn't know any better, right? Now, sometimes I get these things wrong, but in this case, I looked really hard and I was like, I don't think we should do this at the end, guys. This was before we had a PCB layout engine at all. And we decided, okay, we're going to do this differently. We're going to do it at the beginning. So everything on the PCB is driven by rules. Everything is driven by, so some of these things, like you got this GLC PCB 2-layer stack up. When you duplicate that project, it will come with all the constraints built in so that you will design with that in mind. And then you can create your own and drive your project. And it's a faster way of working. And it's a faster way of making sure that you're doing things right. But like, that's like one example, just one example of like us for sure. But at some level, me waking up and being like, okay, it's my job to now go out into the forest, into the dark forest and figure out what is this thing and come back with some ideas. And that's sort of been for me as a product designer from the outside, a tremendous experience. So beautiful to get to learn about this every day. It's really, very exciting for me.
I love that CSS analogy. It makes total sense when you put it that way. I'm like, why isn't it? Why isn't it that way? And honestly, I have always, I only ever recently like decided to start paying attention to the rules in KiCad just because everything I designed in there had already worked in Oshpark, and I'm not doing anything too special. And so I was like, it works, it's fine. But like, you know, bringing that to the forefront and like giving people more awareness and control over that seems really nice. I'm curious. I also designed a couple of Flex PCBs, and people on the internet was like, "Oh, hey, you know," because I also come from like a languages background, and I'm learning all this stuff, and they were like, "Yeah, when you're making Flex PCBs, you got to make stuff smooth. You got to make teardrops for your through holes so that they don't become brittle, and they're when the thing flexes, it's gonna break." And stuff like that, where you know you don't necessarily come in with all this knowledge. Do you have any like plans for things like that, where you're sort of embedding the institutional or cultural knowledge inside of the tool?
I think that's the whole plan. It's the whole plan to and that's one of the reasons why I'm here, is to take the knowledge that I've learned from Apple, the knowledge that I've learned from other places that I've worked, and not a ton of people have access to that information, and we want everyone to have that information. And so you know, maybe in the future, if you're creating a flexible circuit and you have to use curved traces, we should just have that by default, because you know, like you said, people don't necessarily know that you need to do that, otherwise your traces will crack. And so we're sort of doing that feature by feature, process by process, where it makes sense. Ground fields,
like with
are a good
impedance
example.
matching. Oh,
that's right.
No, go for it. Right.
They're both good examples.
I was just so excited the way that Kerry was approaching impedance matching, which is what we're actively working on right now. And you know, one of the problems is that you sort of have to start from scratch again with impedance matching. And Kerry was like, you know, there's kind of just a few sets of things when you care about it. Like USB has some settings associated. What if you just told the system, I'm impedance matching a USB, or you didn't even have to tell the system because it's embedded in the part, because some creator said this is a USB and like this is terminal 1 and this terminal has certain properties. All you have to do as a consumer of this part is show up and go, I'm gonna route you, and the institutional knowledge is embedded inside that.
And even KiCad has like calculators embedded in it so that you can be like, oh, okay, I have this battery, this LED, and this resistor, but you know, you still have to figure out inside of a large system. It could be complex with generic parts. You could be like, okay, I'm gonna make this LED be this you know, forward voltage drop or whatever, and then what it automatically tells you what kind of resistor you need and puts it in, or vice versa. I've got this kind of resistor, what kind of, oh man, so many possibilities. I'm sure you've already been through this, but for me it's like
well, it's what gets us excited every day, right? Because yeah, look, as an engineer, what I wanted was to connect a USB plug to an MCU and not spend the next 3 weeks learning about all the fundamental math here, right? It's like I'm trying to get a job done, right?
And that's not to say that the tool shouldn't allow you to know the fundamental math and execute on that. But for someone who just wants to show up and say, I'm dealing with USB, and you don't even have to say that, you're using USB. You just route it, and the system will use the best practices, which are built into the CSS style rules, to create the right impedance for you.
It seems like a lot of, you know, so much conversation about AI these days and where it's appropriate to be used. And really, I think where all of these things shine is the human-machine collaboration. Like, suggest me some stuff and I'll make it like look nice, or like I'll choose the best one, or like I'll use my knowledge to make sure that it fits with my vision for the project. But also like some of that stuff that doesn't have to be held in our brains can be automated by the tools that we use. I love it.
Yeah, and what was important to us? Oh. Go ahead, Kerry.
I was just gonna say, I love that statement about holding this information in your brain, because I think about this all the time, and I've yelled about it a lot, which is electrical engineers have to hold so much information up here, and none of it is on the canvas. Like, we see, when I route a trace, I feel worried about it going in this region of the board, and I don't want it to go over here, and so I chart a path through it. But why is that information in my brain and not on the board? Like, it should be showing me where the right places are to route. So these are some ideas that we have for the future.
It reminds me a bit of that, you know, old saw about like, you know, at this point it's an old saw, but you know, a lot of us being in school and the teacher being like, you're not going to have a calculator on you all the time. It's like
and we have ChatGPT instead.
yeah. And you know, of course it's valuable to have domain experts and stuff, but also like it really lowers the barriers to people who are coming in from other disciplines. It makes so much sense.
Yeah, exactly. Right. Our dream here is, right, if you think about how simple it is today for like a 12-year-old to build an iPhone app and get it distributed, right? We want to make it as easy to build their own iPhone.
Yeah.
You know? Which is so exciting that Kerry is here, who's actually the only one on the team who has actually built an iPhone before.
Yeah. I gotta get Scotty on here at some point. Have you seen Scotty's videos about building his own iPhone in Shenzhen?
Oh yeah.
Yeah, we talked to him about it.
We chat. He's on our Slack community.
Ah, cool. Okay, everybody get on their Slack because apparently there's some really cool people on there.
But yeah, I think that's really true. You know, it's not that people are going to stop being experts. You're always going to have the Kerrys of the world who are very good at what they do, building the hard stuff. But wouldn't it be beautiful if you empowered more of humanity to solve their own problems with hardware? We've got lots of problems to solve out there. And right now, the keys to the castle are locked up. Is that the right metaphor? You get what I'm saying. It's that there's only a few people who can solve these problems. We have so many. Why can't we have more people solving their own problems, creating desalination for their village, enabling more energy independence, solving IoT problems around the house? Why isn't this happening? Because the tools are hard, because the knowledge is locked up. We need to empower people, right? So that more people can get involved with solving these problems.
I have a great example for this, by the way. For Burning Man, our camp, we switched to all solar power, but, it's like, as everybody knows, it's expensive with the batteries compared to just a generator, and one of the big power consumers next to light is music, And so I was like, man, why are these PA systems so inefficient, right? And it turns out it's just not a design constraint that the manufacturers, which is like off-the-shelf stuff you can buy, design around, right? They don't care about the power consumption of this thing. This is, but you can actually, turns out, make them a lot more power efficient, if you change the design a bit. And so this is something I got into, and I wish that the barriers into that wouldn't have been so damn high, because I think more people would have already done it, and maybe even offer commercial solutions that are more power efficient. But yeah, it's just all incredibly cumbersome. And it's like, right, I think what makes software so much fun is it's so iterative. You can iterate so fast. And in hardware, iteration is like so unnecessarily painful, And so this is, I think, where this came from, that we say, look, like, people always say, oh, hardware is hard. It's going to be expensive and take a long time and it's risky. Let's just not do it. And that's why I want to take the hard out of hardware. I don't think hardware has to be as hard as it is. I think we're making it artificially hard by just using tools from the 70s, Let's change that.
Speaking of the green aspects of it, yeah, there's a huge community also of people who are taking old or retro hardware that might be obsolete, that might not work anymore, and building circuit boards to bring it back to life or to turn it into something else. And like, there's this whole huge community of people who are like excited about retro tech, but don't necessarily, I want to turn, my old radio into a Bluetooth speaker, for example, things like that. And it keeps stuff out of the landfill. It helps people learn about these old technologies, because you got to like take it apart in some way to re-put it back together again or fix it. It's just a wonderful thing to enable. I got to ask you also, Matthias.
Go ahead.
You mentioned earlier that you did animatronics. I just want to hear about that a little bit.
Oh God, we did a bunch of stuff over the years at Burning Man. There wasn't necessarily always a theme, but like I said, I did like a high power efficiency, like large scale PA system. I built a couple of iterations of that. I brought out to the Playa. Then we built like a whole decentralized solar power grid. Like, one of the issues was like, that the camp kept growing and we kept doing different things every year, and we wanted something that was just flexible and extensible. And instead of like having like one large solar system that these are typically hard to extend, we just built like a node-based system where you can just add more nodes as you go, and just like then took some inspiration from the International Space Station, where the power is actually DC power, right? Because that's way more power efficient, but then, you have an issue with like cable length, you're limited there because you lose voltage. And so then this decentralized grid was the advantage, that the batteries would be close to the consumers that way too,
Yeah.
And
have you shared this anywhere? I'm really curious.
Yeah, no, there is a GitHub repo actually. It's on my list to turn this into a Flux project, but in the meantime, there's a GitHub repo. I'll
I would
find
love
that.
to see that. Very interested.
Give me a second here while we're talking now.
Perfect. And yeah, so we're almost at time here. I want to make sure that we get a chance to cover everything. Just before we do that, everybody go to Flux.ai to learn more about this. You can follow Flux on Twitter at buildwithflux. Matthias is on there, Matthias Wagner. We've got Brooke Solvig, and I think Kerry, either we didn't have your username or maybe you're not using Twitter for whatever reason, which is chill. But yeah, if you'd like, we can put it in the description after. But yeah, everyone, that's where you can follow. Any last comments or ways that you would like specifically for people to get involved or upcoming announcements you'd like to share?
I just shared the link to the ARCs, what we call them, this decentralized solar system, here in the private chat, so you can share it out.
I will do that.
Well, you know, we like I mentioned, we've got some competitions going on in the Slack community. There's a one that we're voting on right now, and then you can get involved in the next one. We did just come out of beta, like Alex mentioned, middle of last month. So it would be awesome if you'd come on down and sign up and build a board and tell us what you think. You know, we're still working on some things, right? Like we mentioned, we're actively building impedance matching right now. So would love for you to come on down and tell us what you like, what you feel is missing, what you think we should work on next. That really matters a lot to us. We really listen. Yeah. Anything else, guys?
No, yeah, definitely. You know, join the movement here. There's tons of fun stuff to do. We are all fun people, I think, you know. So come hang out with us on Slack. Yeah, don't hesitate to ask questions. Yeah.
And you're hiring some folks.
Oh yeah, and we're hiring. Yeah,
I mean,
we're hiring software engineers left and right. We are hiring hardware engineering interns. And we're also hiring a social media marketing intern. If you want to run our Twitter for us, join.
Oh yeah, that's linked in I believe in the footer of the page. So go check that out. All right, yay! Thank you so much for joining. Yay! That's not the catchphrase, but thank you so much for joining. This is a lot of fun, and I'm excited to play around with these tools some more. I can't believe I get 10 private projects before I have to show people what I'm working on. That's amazing. But then yeah, so cool. Thank you all again, and thanks everyone
It was great to be with you.
Yeah.
Thanks for having us, Alex. This was so much fun.
Awesome. Yeah. Come back anytime. Thank you to all the audience members, especially those who dropped comments in. We'll see you soon and hack on!
Woo!